Hello everyone, my name is Mingda Zhang and I'm very excited for this opportunity to present our work, how to practice VQA on a resource-limited target domain. This is joint efforts with my advisors Rebecca and Adriana from University of Pittsburgh. Visual question answering has been an active research area in the past few years, with multiple large-scale datasets created and many novel methods proposed. State-of-the-art models have achieved very competitive performance on multiple benchmarks. However, one realistic obstacle that prevents its broader application is the lack of annotated data in the real-world problems. The discrepancy can occur in both visual and textual modality. Various domain adaptation strategies have been proposed to mitigate the issue, but in this multimodality setting, there also exists many challenges. Specifically, different adaptation strategies have varied sensitivity and requirements of information about the target domain. For domain discrepancy-based approaches like moment matching, it doesn't require any answers and only focuses on matching the intermediate feature statistics from target to source. Usually, only the encoder part will be affected. For self-supervised reconstruction, it aims at recovering the mask token, thus producing a more robust representation. For supervised auxiliary co-training, the adaptation applies to the entire pipeline. In this work, we investigate various domain adaptation strategies and show the most effective approach, which leverage both labeled and unlabeled data. Assume DS and DT are two datasets that we have access to for training the model. For DS, it contains image question answer triplets and has sufficient examples for properly training a model. However, for DT, it is sparsely labeled and the number of examples are much smaller, preventing direct training or fine-tuning. Our task is to obtain a competitive model on DT which preserves its knowledge from DS despite domain gaps. The overall training objective is shown below, and for different domain adaptation strategies, we adapt different objectives during training. Next, we show the comparison between self-supervised adaptation and fully supervised co-training. In this setting, the source dataset contains 60,000 triplets while we test two different target datasets. By adding different amount of target examples into training, we show the sensitivity and effectiveness. In the most extreme case, even adding 0.1% of unlabeled target examples can boost the target prediction accuracy. The green curve indicates supervised auxiliary co-training, and since the ground truth answers are used, this is sometimes referred to as upper bound. However, we observe that self-supervised signals actually complement the ground truths where target resources are extremely limited. In fact, combining both can achieve even higher performance. We also probed different modalities with a plug-and-play discrepancy-based domain adapter, which is the unsupervised moment matching. The overall improvement is not as significant as self-supervision, but we observe very interesting patterns. For example, reducing domain gaps on an individual modality may even hurt the overall performance, as cross-model interactions may be affected in this setting. Also, placing the discrepancy-based adapter closer to the final prediction head works best. Next, we took a closer look at question-characterized subdomains. Specifically, we trained multiple models with a full source dataset together with questions just coming from a single subdomain from the target. We did some normalization to account for the intrinsic difficulties. We see some patterns like training an object recognition question enables model to answer reasoning and verification very well. However, if trained on verification questions, the model seems to only learn how to make binary decision on the target domain. Lastly, we demonstrate that co-training with the same type of question help model gain specific capability like counting and color recognition. But for unsupervised moment match, it even has negative effects for almost all categories. Our hypothesis is that matching moment statistics may require diverse data for an accurate estimation. Thank you for your time and interest.